on a conditional basis, or if I give you conditions, what's that mean? Oh, hang on, like 5 of y'all just tried to talk to me at once and the ADHD heard none of it. Good. Like if I give you conditions, you can go to your friend's house if, or like maybe you got in trouble with your mama or daddy and they're like, you can have your phone or your car or your game system back if. Yeah, you got to do something, right? So conditions means something has to happen. Does everybody agree with that? Okay, that is what conditional probability is. So conditional probability, if you look, I gave you a formula and I gave you a definition, is the probability of an event occurring given that another event has already occurred. You're going to want to highlight that. My people at home, if you are writing, you're going to want to write that definition. So conditional probability is the probability of an event occurring given that another event has already occurred. All right, so when we're finding the probability of one event given that another thing has happened, that is going to reduce the sample space. So if I'm reducing the sample space, can somebody tell me what I'm making smaller? What part of the probability? Where's the total number of outcomes go? There you go, in the denominator. Good. So if we're reducing the sample space, our denominator is no longer going to be out of the total. That's what's so tricky about conditional probability is you guys are so used to putting everything out of the total. This is where you'll mess up, okay? So given probabilities are going to reduce our sample space, so the denominator is going to decrease. So then it says, in other words, the denominator will not be the total number of all possible outcomes. If you are somebody writing at home, I would just write this part. Given probabilities, reduce the sample space, so the denominator decreases. So what if I said, we're all going to write this down. What if I asked you to find the probability? I'm going to talk about cards again because some of y'all look like you need help with those. The probability of drawing a 4 given we draw a red card. I'm just picking one card. So that little bar right there, it's on your paper. That bar means given, okay? What did we just write down that the word given does? Given probability is what? Make the denominator smaller. So y'all look, wherever that bar is, what's behind it or underneath it tells you what your denominator should be. So everybody look at this. If it says given red, how many red cards are in a deck of cards? So this means I'm only looking at the 26 red cards because I'm telling you I pulled a red. Does that make sense to everybody? So what's the probability if we pulled a red that we get a 4? 2. Why? There's only 2 red 4s, right? The red of heart, or the 4 of hearts and the 4 of diamonds. That given red means it has to be red. That's the condition. What is 2 over 26 reduced to? There you go. Good job, y'all. 1/13. Let's try another one just to make sure y'all are okay with where we're going with this. So the probability of drawing a spade given we drew a face card. If I'm going too fast or if it doesn't make sense, I need you to let me know today. Yes, ma'am. The slash is the given. Yep. Look at the first sentence on your paper. Given, or it's a vertical slash. So what comes after that tells you what the condition was. So what's my condition in this probability? What do we have to draw? What are we looking at? Face cards. It comes after. Given I drew a face card, what's the probability it was a spade? So let's think about it. Remember what I told you. Remember the trick. Whatever comes after the slash, that's your denominator. So how many face cards are in a deck of cards? 12. Very good. How many of those 12 are spades? 3. There's a jack of spades, a queen of spades, and a king of spades. So what is 3/12 reduced to? Good job, y'all. What questions do we have about basic conditional probability? That's really all it is. I'm going to pause. Feel free to ask me. Both of y'all extra credit. Are we going to use these for inclusive and exclusive or just inclusive? Anything. Okay? Any probability can always be asked of any kind of event. So inclusive or exclusive. So if you look on the front, I gave you a frequency table and a Venn, right? Those are inclusive. If I give you an inclusive diagram, I need you listening. I give you an inclusive diagram, you are not using this equation. It's just like what we did yesterday and Wednesday. I had to think about my days. If it is inclusive, you look at your diagram and keep rolling. When do you think we use the formula? When it is exclusive. And we'll write that down in a minute, okay? But it's just like the stuff we did yesterday and the day before. Make sense? So basically, if it's a word problem where you have to draw a tree, that's when you're going to use the formula, okay? Anybody at home have any questions? Those were 2 really good ones. So we're going to start off with inclusive examples. So if you are somebody at home kind of following along with these, I don't need you to draw it like in your notes. I'm okay if you just like follow along and answer the questions with us. But what I do need you to write in your notes, oh my God, not your nose. That'd be crazy. Everybody should write this. If they are inclusive, you are not using the formula. If I see you doing a formula for a Venn or a frequency table, it's like you're going to get it wrong. I'm letting you know. It's going to be wrong. Because when you have made frequency tables and Venns, you've already like narrowed down the different types of conditions. Okay? So you do not need the formula. So looking at this frequency table that they gave us, and I'm going to zoom it in for y'all. The question, do you play football, was asked of 110 students. Results are shown in the table. And before somebody tries to be sexist, girls can play football. So don't try to be funny. I feel like I could outsport probably half y'all boys in here, so don't play me. All right. Jordan, don't you do it. Don't try me. If you look at question A, it says, what's the probability that they play football? What does this bar mean? Given they are a what? Boy. Who are the only people I'm looking at in this table? Boys. It says given they are a boy. So I just narrowed down my sample space to only who? Only boys. So can y'all tell me what my denominator is going to be? 75. Very good. If you joined late, conditional probability means that we're only looking at a certain part of our sample space. So it's not going to be out of the total anymore. So given they're a boy, that would be 75. How many of those 75 play football? 42. Very good. that does reduce, it would be, I'm going to help y'all out, 14 out of 25. Does that make sense? There's like, it's not hard when it's out of a frequency table. It's very easy to look at because they've already like separated each type of condition. Okay. All right. What's different about B? Yeah, good. They flipped it. So this one is saying, what's the probability that they're a boy given the person plays football? So who are the only people we're looking at? Who'd we narrow it down to? Football players. So how many people total play football? 54 is your denominator. Very good. Out of those 54, how many are boys? 42. 42 over 54, let's see, they're both divisible by 3. I think it's just 3. Am I wrong? No, it's 6. You're right. There we go. 7 over 9. Very good. Extra credit, you two. I did show y'all a while back, like first unit, how you tell something's divisible by 3, right? Oh, yes, I did. I know I did. You might not remember. 4 plus 2 is 6. That's divisible by 3. 5 plus 4 is 9. That's also divisible by 3. So I knew this was divisible by 3. There's a trick for 3s. There's a trick for 9s. There's a trick for 4s. Basically. But only for 3s, 4s, and 9s. That's the only thing it works for. Okay? All right. C. Probability they do not play football given they are a what? Girls. So who are the only people I'm looking at? Girls. So do y'all agree this would be out of 35? And don't play football would be 23, and 23 is prime, so that does not reduce. Any questions on conditional probability from a table? Everybody's good. We're good with frequency tables. So the only way they can make this harder, y'all, is if they don't draw the given symbol and if it's written in like word form, kind of like a word problem. So like the way you'll see it worded, if they don't draw you the symbol, I hope we're all listening because this is what's on your homework. You'll see it or hear it worded like, what's the probability they play football if they are a boy? So that word if also states or shows that it's a condition, okay? So look for that word if or look for the division bar. Okay, Venn diagrams. Venn diagrams aren't bad either, but you have to remember that a given or conditional probability narrows it down. Is everybody with me? Okay, so check this out. I already drew the Venn for you. If you're somebody at home, you can copy the Venn, but you do not have to. Just follow along with us. Venns are still inclusive, so are we using the formula? No. Everybody look. Biology, given they take chemistry. Who are the only people we're looking at? Chemistry. This is why I asked you to grab some highlighters. I highly recommend for Venns circling your given circle because those are the only people you are looking at. If you don't circle it with a color, every year I have a kid try not to do it. They mess it up eventually, okay? Because there's a lot going on in a Venn. The circles overlap. It's sometimes hard to tell what you're looking at. I totally get that. So given they take chemistry, how many people did I circle in this green chemistry circle? 27. Very good, Keydrian. All right. Out of these 27 people, which means I'm looking at the people where again? The green circle. Out of those people in the green, which ones also take biology? The 13 in the middle. We're not asking about the 17 over here in the biology circle because it says given they take chemistry. So those people do not take chemistry. We're not talking about them. Does that make sense? Everybody's good? Okay. Second one, given they take biology, which means I'm looking where? Yeah, only in the B circle. So I'm going to make it blue. Given they take biology, so in the blue, which means that's how many people? 30, good. Heard somebody say 30. How many of those 30 take chemistry? Just the 13 again in the middle. Very good question. That's where it gets dicey, and that's where you definitely want to use colors. He said, what if we have 3 circles? So let me add, can I add in a third circle for you? Let's make it dicey. You don't have to, people at home that are like actually writing all this out, gosh, that is so ugly. I hate my artistic abilities. The Lord gave them to somebody else. He didn't give me no sprinkle of art. If you're somebody who's writing this at home, you do not have to draw this. Again, if you're somebody who printed it out, I highly recommend drawing this. So let's say we add in, I'm just going to get rid of that 99 for now. I don't know. Let's add in math. Why not? And let's say 12 people just take math. Let's put 10 here, 9 here, and in the middle, I'm going to put 7. So another thing they could ask you, I'm going to make it a little tricky. Is that okay? Yeah? Okay. What, baby? Yes, I do. Yep. What's the probability they take all 3 given they take at least 2? So I'm going to pause and make sure everybody has written this down. It's a little trickier. So where are your at least 2 people? Because I see a lot of you figuring it out. Where are all my people that take at least 2 classes? Yeah, in the overlaps, right? So does everybody agree? I'm going to highlight this in yellow. The people who take at least 2 classes, these 10 take at least 2. These 13 take at least 2. These 9 take at least 2, right? But also these ones in the middle, they take at least 2. At least means 2 or more, right? So they take all 3. So my at least 2 should be out of what? How much? 39. Let me double check, y'all. That's 23 and 9, which would be 32 plus 7 is 39. Good job. So out of 39 that take at least 2 of the classes, how many take all 3? Very good. Do we feel like we could do conditional probability from a Venn? Sean, are you with us? Pick that head up, dude. Thank you. We feel like we could do conditional probability from a Venn. What's your question, baby? 7 people took all 3. They're in the middle. You might not be able to see it back there. I'm going to pause. What questions do we have on conditional probability from a Venn? So before we flip to the back, if you are somebody that is at home writing, I need you to write this. And people in class, you should put this on yours too. When you have exclusive events, that is when you can use this formula. So I'm going to give you a second to copy that down and then we'll talk about it. So if the events are exclusive, you can find the probability of event A happening given event B happened if you put B as the denominator, which is the same thing we were doing, right? Is everybody looking? And then you put the probability of the intersection or both happening in the numerator. Because, check this out, ideally, if you were like trying to simplify something, let me just show y'all. I feel like I need to give you an example. Like if you had 3x divided by x, what happens with the x's? They cancel and you find 3, right? So if you want to find the probability of A given B, put A and B in top, put just B in the bottom, and ideally what would happen with the B's? They cancel and you find A, which is what we're trying to find. The probability that A happens given B happens. Does that make sense? You need to know this formula. A and B, you could also see it written like this, go in the top, just B goes in the bottom. That'll tell you A given B, but only for what kind of events? Thank you. Don't you dare do it for an event or a frequency table. I'm going to be upset. Everybody's okay? All right, so let's flip to some exclusive examples. I've got them on the back for you. All right, this should look really familiar. What's it look like? Number 3 from yesterday's classwork. Good job, you 2 extra credit. So bag P contains 3 yellow balls and 5 green balls. So everybody look, how many are green? What did it just say? 5 out of 8, very good. Bag Q contains 4 yellow and 1 green. So this should be 1/5. Now this is where some of y'all messed up on the classwork. This is still bag Q, so it's still going to be 4/5 and 1/5. We talked about that a little bit yesterday when we did our trees. So if it's represented by a tree diagram, what kind of events are these? Exclusive, very good. So what can we use to find our given probabilities? The formula. Is everybody with us? Yes? Okay. So if you want to find the probability that you draw a yellow, given you drew a yellow the first time, what's going to go in the denominator? Okay, yellow from the bag P, the first draw. Given you drew a yellow the first time, you can't say given you draw a yellow the second time, what happened the first time? That doesn't make sense. Trees go in order. So given you drew a yellow the first time, which means our probability in the denominator is 3/8. Good. What's the probability that you also drew a yellow the second time? And this is where y'all will mess up. Nope. It's not 4/5. This is where y'all mess up.
You have to add both of them, right?
Not add. You're very close, though. Yes. Good, good, good. Okay, stop. Good. Remember, when you are doing a tree, Sean, you ain't paying attention again, dude. I ain't got office hours today. And your mama going to be mad if she has to help you. Everybody look. When you're going from branch to branch in a tree, I'm saying this thing happens, and then this thing happens. So what are you supposed to do with these 2? Multiply them. Good. So the numerator would just be 3/8 times 4/5. Can somebody tell me why that makes sense? You might want to look at what you wrote down a second ago. What you gonna say, Jaden? This is A given B. What's my formula? What goes in the top? A and B. What's the word and mean? Multiply. So I'm going to do A times B, put it over the given one, which was this one, right? And then what happens with the 2 3/8? They cancel. So L'Oreal, what's the final answer? 4/5. Can somebody try to explain to me why that makes sense? Do you think, let me lead off with a question actually, so I can get y'all's brains working a little bit, because some of y'all look like they ain't half turned on today. Do you think we will always end up with a given probability with one of these answers? You're right. Why? Why? Why do you think you will always? So I'm telling you, on a tree, if it is a given, you should always end up with one of the answers on the second branches. Well,
The
that's
numerator and the denominator will always cancel out.
good. That's what they said too. But and that's right. You're right. Why do you think they'll always cancel out? You know, I'm about to ask you why about 4 more times. Because they're both B, but why, like logically, why would that work? They won't always have the same denominator. They don't actually. Oh, okay, hang on. Let's think about it. But think about the scenario. I don't really want you thinking about the numbers right now. I want you like thinking about in the real world, when would this happen? If I'm saying bag P is you drawing a marble the first time, right? Is everybody following me? So I'm saying given we draw a yellow the first time. Look at your tree. That automatically means we're only talking about what part of the tree. Given I drew a yellow the first part, the first time, which part of the tree am I talking about? Just the top half. If I'm telling you given we drew a yellow the first time, that is only this branch and whatever comes off of it. So given we drew a yellow the first time, which means I'm just looking here. So do you really even need this part? No. Given I drew a yellow the first time, what's the probability I draw a yellow again? 4/5. Given you draw a yellow the first time, what's the probability that you'll draw a green the second time? It's just 1/5. You can use your formula. Absolutely. But that's why I said you can only use the formula with exclusive. And I said the word you can use it. Did I say you have to? Don't have to. Yes, ma'am. The formula is really just an extra step. You don't need it here. Because I'm saying, given you drew this the first time, that means we're only looking there. And I don't even care about that number because I know that happened. I'm really just concerned about those. Which of those is going to happen the second time? We'll do it with the formula again just so I can prove it to y'all because some of y'all looking at me like, what? Given we drew, what's the probability we find a yellow or we draw a yellow? Given we drew what the first time? Green. So what's the probability we draw green the first time? That's our denominator. 5/8. Very good. So looking off of that green, because I'm telling you we drew green the first time, right? That's what that word given means. Given I drew that green the first time, what's the probability I then draw a yellow? 4/5. Now, did y'all hear what words I just said in between that? Given I drew a green the first time, what's the probability that then I draw a yellow? What do you do when it says and? Or when you jump from one branch to another? Say it again, Carter. Multiply. Good. So everybody look, you would do 5/8 times 4/5 if you're using your formula. What happens with the 2 5/8? They do, and the answer is just 4/5, which is what was right there on the second branch. You can always do that. Yes, it is. Didn't we say it's always going to do that, right? All right, let's try one more. Probability we draw a green, given we drew a yellow the first time. What's the probability that we draw a yellow the first time? 3/8. Very good, Soraya. So remember your formula. I'm just going to remind you. I'm going to write it again. It's A and B over B. So there's my B, yellow. What's the probability that both of these happen? So yellow and then green. What do I do with these two numbers? Multiply. 3/8 times 1/5. And a lot of y'all are looking at me like, why is she still doing that? What's the answer? It'll just be a 5/5. So I'm going to pause and see what questions we have about trees and the formula. On your test and on one of your classworks for next week, once you'll have like a hang of what's going on, I may ask you what's the probability that something on the first branch happens given the second happens. Of course I would, because I got to make it challenging because you're honors kids. So yes, that was on the exam 2 years ago. And kids like wigged out. It's actually not, it's not that bad. You do have to use the formula then. You can't jump from the second branch back to the first. But we will get to ones like that, yes. But not today. I don't want to overwhelm anybody. Before I move on to the next section, I want to give you an example where they didn't give you a tree. Does that make sense? Is everybody with me? We're paying attention? We're writing, I hope. So write this example down. The probability. We're going to talk about pets. What two pets do y'all want to talk about? A dog and a? My girl said a zebra. A dog. Let's do a what? A hamster. I like that. That's cute. A zebra. I'm pretty sure owning a zebra in city limits is probably against the law somewhere. That's probably written somewhere. So the probability that someone owns a dog is what percent do y'all want to say? I feel like it's high, probably 80%. I like that. The probability that somebody owns a dog is 80%. The probability that they also, that's a key word there, probability that they also own a hamster. I feel like I spelled that wrong. Does that have a P? I don't know. I'm Southern, so hamster sounds like it has a P. All right, the probability that they also own a hamster is what, like 25%, 30%? We'll say 30. It's 30%. Find the probability that they own a hamster given they own a dog. So I'm going to pause while everybody gets that written. I highly recommend writing this. Hint, hint, wink, wink. I know some of us may still be writing, but he just asked a great question. Can you own a dog and a hamster at the same time? You can. Now, have we ever done a Venn diagram with percentages? No, because it gets pretty dicey. I'm not saying that you couldn't. You can. But there's an easier way to do this. So I'm going to actually retract one of my old statements. Y'all know what that means? That's a lawyer term. What's retract mean? Y'all going to say yes, but not tell me. Take it back. You can use the formula for anything if, I'm giving you a condition, if they didn't give you a diagram. So was I given a diagram here? No. So I could use the formula if I wanted to. So let's talk about the formula because I want to make sure y'all understand it, because if you know that formula and can use it, it's actually faster than drawing a Venn here, okay? Given they own a dog, that's my condition. So how many people own a dog? 80%. Can you change that to a decimal for me? 0.8. Good. So given 80% of the people own a dog, we're using our formula. What would go in the numerator? How do you know 0.3 would go in the numerator? He said it's the other percentage. I mean, you're not wrong. Can you talk to me about the formula, though? What goes in the top of the formula? Huh? A and B. Everybody look. Because I could give you more than just two percentages. I was trying to keep your hand right and short today. What goes in the top is A and B. So the probability they own a dog is 0.8. If I'm trying to find given dog, hamster, given dog, hamster and dog have to go on the top. So it says the probability that they also own a hamster, which means they own both, right, is 0.3. So if you do 0.3 divided by 0.8, we're going to put the answer as a percentage since they gave us a percentage. Then the answer for hamster given dog would be 37.5%. If anybody wants to see how you would do the Venn for that, you can hang back after I'm done in a second and I can show you, okay? But in all honesty, that's way faster if you know that formula. So as long as they don't give you the diagram, you can use the formula. Yes. How did I get 0.3? Because it says the probability that they also own a hamster is 30%. Tell me my given formula again, because y'all don't know it. Tell me my formula. What's my formula? My goodness, reading is so hard. A and B over B. Here's A, here's B. So given B, dog goes on the bottom. A and B goes on the top. So if it says the probability they also own a hamster, that means they own a dog too. So that's the and right there, 30%. That's okay. I gave you the words a little tricky. They give you symbols, that's really easy because y'all know what they mean. Trying to give you all types of examples so you're prepared for your practice classwork on Monday. So what? No, you don't listen, everybody. You're not multiplying 0.8 times 0.3 because 0.3 isn't the probability that they just own a hamster. That's the probability they own a hamster and a dog. That's a great question. Is everybody okay? Oh, that's a great question. What's the percentage of just owning a hamster? So here's where a Venn would get dicey. I can draw it for you real fast. I don't like doing Venns for these, and you actually can't do it for this one because I didn't give you enough information. 80% of people own a dog and 30% also own a hamster. So that means this would be 0.5, right? You can't assume that that means 20% goes here. Because what if they don't own either? You get what I'm saying? Very hard to do a Venn here. Now, it actually wouldn't matter because it said given they own a dog. Y'all look, because I'm actually showing you here on the video. So given dog is right here. Isn't that 0.8? How many in that pink circle also own a hamster? 0.3. 0.3 over 0.8, you still get the same thing. So if you're visual and you want to draw it, go right ahead. All right, I'm going to keep trucking. I want to make sure we get through everything. We're not going to do all these examples either because y'all are honors babies, so I feel like you can figure it out. Who can tell me what an independent event is? What do you think? What's the word independent mean, first of all? On its own. So like if I was drawing a card, then I put it back and then drew another card. Do you think that's independent? Yes, why? I agree. Let me get out my cards. Because what? No. Okay, hang on. That's great. You're backwards though. You got a deck of cards. They're actually face 10 cards, but we're going to pretend they're regular cards. Everybody's watching, correct? Independent, dependent are different from inclusive, exclusive. They're different. So whatever I draw from this deck the first time, if I leave it out, then I'm one less card, right? So whatever happens next does depend on what I did first. Do we agree? But if I said you put it back, does what I draw next depend on what happened the first time? No, because I put it back. Okay? So independent events, if you are writing at home, you're going to want to write this. Independent events are just events where the first event has no effect. Would that be E or A? I think it's E. No effect on the second. I know that's small. If you need me to read it to you, I can. So what does that mean about dependent events? Yeah, so what you do the first time does affect or could affect what you do the second, right? Good. So the first event can affect the second. I'm going to pause and let you write. So I did go ahead and give you your formulas. You're going to want to know these. If A times B equals A intersect B, they're independent. If A times B does not equal the intersection, then they are dependent. Once y'all get those written down, I'm just going to do one example because I want you to have homework time in here with me. Even though there are not Zoom office hours today, if you need help on a question on the homework, which it's only 5 questions, but if you need help on one, you need to shoot me a message and I can help you set it up on my app, okay? There's also office hours on Virtual Monday, which half of y'all never come to. Half of y'all don't do your work on Virtual Mondays. And then you do get a late grade. It's not a vacation. So if I ask you to determine if 2 things are independent or if they're dependent, all you got to do is multiply them and see if it equals the intersection. If it does, they're independent. If it does not, then they are dependent. So y'all look at example 1. It says determine if they are dependent or independent. So what would you do? I'm going to take A, 2/5, multiply it by the probability of B, which is 1/5, and figure out what that equals. So what is 2/5 times 1/5? 2/25. So Jaden, let me ask you a question. Does this multiplication equal A and B? Okay, what's your formula say? If they're equal, what does that mean, Evan? It's independent. Very good. If it did not equal the intersection, then what would I say? They're dependent. So I feel like y'all could do number 2 just without me. People at home, you can just look at it. If I do A times B in number 2, is it going to equal the intersection? No. So what does that mean? It's dependent. That means whatever you do with A or B, like whichever one comes first, it affects the other one because it doesn't equal the intersection. So they're dependent. Did that make sense how I worded it just then? If you multiply them and they don't equal the intersection, that means one of them affected the other one, and it won't equal out to be the and. So it's dependent. Okay, I'm going to stop here for today. I think we'll do 3 and 4 as like warm-ups when we come back next week. Your classwork is short. It's going to look like a lot. It should not take you a while, so I want everybody to just look at it really quick. And I think I'm going to be really nice, actually, and omit number 2. So you're welcome. I hope we're still watching. You don't have to do number 2, so it's literally 4 questions. You have a frequency table. You have, I want you to do these 2 card problems. You got 2 card problems. Oh, that's number 3 anyways. Ha. So you're doing that one too. That's talking about cards. And then you've got some independent, dependent questions. Sound good? Any questions for me before we get going? People at home, any questions?